Welcome to the Career Builder series, a practical SAS statistics and data analysis course for complete job seekers and beginners. So why should I take this course, and what does this course aim to teach? The distinct teaching approach consists of minimizing SAS programming and statistical jargons, making things simpler for you to understand. Improving programming by many hands-on and practical use examples. Explaining statistics and output in plain words, once again to simplify things for you to understand. Career-oriented. So we have many practical uses that are used in industry and business, and we supply answers and explanations so you can methodically understand every step. The goals of learning are to master SAS programming to solve practical analysis problems, such as data mining, data analysis. We also form the foundation for later courses in the Career Builder series. And now for the big question, what will I take away from this course? From this course, you will learn to conduct data extraction, merging, and exploration. Okay, now it's time for our first example, so follow me. Here is an example of a text file with student information. So it's a data set we want to arrange into rows and columns. But how do we do it? We pull the data into SAS and create a SAS table. But how can I write the code? First, define the SAS datasheet, then specify the path for the data. Next, input corresponding column and name information to match the text file, then run. The result is a small, organized data set. We will now use our first SAS table, so follow me. If we have such a SAS table, then we want to use SAS SQL query to summarize the data. Now to create the code. First use procSQL. We want to list all students under the condition of age less than 20. We also want the average for male and female as well as the number of students for each gender. And now for our next example involving two SAS tables. Assuming we have two SAS tables, one with 4 records and one with 2 records, we want to merge the tables according to gender. But how do we do this? First, the data is merged, the final resulting table. We merge SAS table named student with a second table named sum table. We merge by gender, and then run. The final result is the table shown below. Alright, now the second takeaway is how to manipulate the data set. We have a SAS table. We want to split the data set into 2 tables. One for male, one for female. But how do we write the code? We use an if-else statement. So if gender equals female, then output equals female, else output equals male. And then we run. The final result is the table shown below. Here is another example called a sliced data set. Slicing means to only extract a subset from the original data set. But how do we do that? We copy the original data set named student. We create a subset called good student, which is a new data set. Set the first data with the condition of greater than 85. Then run. The result is one table showing grades greater than 85. This table is a subset of the SAS table student. Next, we have what is called a reshape or transpose. We will use the same SAS dataset named student. We will use proc transpose. Out equals trans is the final output, or a new dataset named trans. By gender, and var is by age, and then we run. The dataset was vertical in student, and now it is horizontal in the new dataset. The next takeaway is perform quality control, QA/QC. That ensures data integrity and compliance by performing data audit and/or data validation. Follow me. I want to clean the dataset by filling the missing values. This is impute. We impute the missing values. We use proc, standardize, and use mean to fill missing data. Output is car_fix. var price kilometers. These are the only two columns missing the data. Then we run. And the result is shown below. As you can see, the data has been filled. Now for the next takeaway. To proficiently program on SAS and master comprehensive analytics methods in data analysis. Follow me. Assume we have the same data set, and we want to provide descriptive statistics using proc means. CLM is confidence interval, and we only want to track the price of different automatic systems. var is price. I only want to check the price. Then we run. And the final result is shown below. This is an example of binary variables. Follow me to the next example. This example is about stock price. Suppose we have 3 stocks corresponding to the price over several days. We use SAS function and array. I want to calculate the average price of 5 days. Simply use the mean function. I also want to calculate the amount of change for consecutive days using array. Then we run, and the table is shown below. Follow me. This example is about the frequency cross tab. Use proc freq. The original dataset is called education_income, but I want to check the count or percent ratio of education corresponding to high income. Then we run. The result is the table shown below. Follow me to the next example. The next example is bucket analysis. What is it? To assign each of the ranking of a group. For doing so, you can easily check the data pattern. For example, I want to separate the candidates into 3 columns according to the number of votes. I use proc rank in SAS. Group equals 3, out equals results 1, and var equals vote. var is the bucket in terms of the vote. Then I run. The output will have additional columns, 1 additional column showing membership of bucket. A bucket is 0, 1, or 2. The next takeaway is to create new features, transform and select attributes in the existing data to support advanced analytics. Follow me to the next example. The next example involves a bank account. I want to create new attributes. I'm using the SAS data step programming method. Use it to create a new variable, such as utilization. In this case, utilization equals balance divided by limit. Age open equals account time open, and today's date minus open date divided by 30. Then run. 2 additional columns are created, as you can see in the table. Now for the next takeaway. To produce and carry out various types of maintenance for professional dashboards and reports. Follow me. Assuming this is a transaction table, retail transaction table. Now I want to create a tabular report based upon time and type. I use proc tabulate. var using var amount, class, statement, months online and type. Then create a table by tracking the mean value of the amount under each category. Then run. The result is a tabular report. Graphics and visualization. To perform data visualization using SAS graphics tools to aid data understanding and analytics. This type of training is very rare in the SAS training market, so an added benefit of this course is that you will learn it here. So follow me. This is service data. to track coffee consumption based upon demographic features. I want to generate a chart based upon the amount of coffee for different genders and education. The final result is a 3D chart. Correlation studies and linkage analysis. To detect linkages among the features in data and detect business KPIs, key performance indicators. Follow me. This is about car price. We're conducting a correlation study. We run proc core. Output is a Pearson correlation table. var is price. I want to check the correlation of price with the following variables. Then I run. First, here is a correlation value between price and these variables. Second, by ranking the correlation coefficients, you will know which variable is highly correlated to the price, so that we can make a prediction. To effectively apply data and analytics to conduct sampling, standardization, and translate the quantitative results into meaningful outcome. Follow me. Here's an example. The job is to do a random sample from a whole population. Then I will copy the dataset using the uniform distribution function, assuming that I want to take 50% of the sample size. Then run. The result is a subset of random sample of the original population. And now we will perform various statistical procedures and read and understand real meanings of various SAS outputs. Follow me. Here's an example. We have survey data that we want to run an ANOVA F-test by comparing the income based on the different levels of education, gender, and employment at the same time. So we use the proc ANOVA to run an F-test. Then we run. The results? We can track the p-value in output table to know which factor can cause the difference in income value. Also, you can understand for the different level of education whether their incomes are different. Efficient data management. Data management is not data processing. Here we are focusing upon data dictionary or data structure rather than data contents. Follow me. Here's an example. We want to look up data dictionary for employee information. Run proc contents. Then I want to see the variable name, type, and format for that table and send it to the output table. Then I run. The results, as you can see, it lists all the data dictionary information that you may want. Building data automation systems using SAS Macro. I think that this is the most amazing part of SAS because it can help you save a lot of tedious tasks by automatically performing these activities. We can also use SAS to create monthly or yearly reports without any interaction or maintenance, and that can be very convenient. Here I have many tables with some data structures. For instance, they are consumer accounts with mortgage balances. Now I want to summarize using SQL for the monthly data sets automatically. Now I write SAS macro function using the do loop. I simply put the number of months in the loop. Then SQL will be executed for all 5 tables automatically. I will get a final resulting table, which is stacked of all the summaries. And now to summarize. This course covers the most complete contents in SAS programming and statistical knowledge and skills. You will master SAS as a tool and use our data analysis cases as experience to start a career in data science. It's a good starting point to learn advanced data mining and machine learning courses following this course. Many tests and homework and answers for reviewing and improving your skills.